Oh yes, we've got more normal distributions. And this is question number 3. So here we go. We've got bowls are made by maths crockery manufacturers with a diameter of d centimeters. The diameters can be modeled using a normal distribution. And there's our normal distribution there. So we've got a mean of 19 and a standard deviation of 1.5. And what we need to do is work out a couple of little problems as seen over there. So get cracking and we'll catch up in a couple of seconds to go through the solutions. Righto, it is solution time, so let's get cracking. Now our distribution tells us that the mean is 19 and our standard deviation is 1.5. So jot those down straight away, that's really important information. Next, we're told that 70% of the bowls are less than x centimeters and we need to find what x actually is. So I think we should make a sketch again. So there we go, there's our bell-shaped curve and our mean right in the middle there is 19 centimeters. And we're told that, x is somewhere and such that 70% of the bowls are less than x. So that tells me x has to be on this side because the area therefore to the left of it needs to be 70% or 0.7. And now what do we need to do? We need to find out what x actually is. Now, whenever you've got area to the left and you've got your mean and standard deviation, what you need to do is use what is called the inverse normal function on your calculator. So let's head over to the inverse normal function. So we've got that there and we're looking for option number 3, inverse normal. So hit 3 and it brings this up here. So area, remember area is always area to the left, okay? So left hand side. And so the area to the left of x is 0.7. So I'm going to put in 0.7 as my area. The standard deviation is 1.5 for our distribution. So let's get 1.5 into there. And the mean is 19. So let's enter 19 as our mean. And there we go. That gives us what x is straight away. So x is 19 point, we'll go 787. There we go. So that's that bit done. And now what do we need to do? We need to find the interquartile range of the bowl's diameters. And so what we should do is make another sketch, right? So we'll sketch this out. Bell-shaped curve, there it is. Mean in the middle, which is 19. And now our lower quartile, remember lower quartile represents like the lower 25%. And so if I put that in there, I'll call this y. That represents our lower 25%. So 0.25 would be the area to the left. And so we just need to stick with our inverse normal and we'll put 0.25 as the area this time. Our mean and standard deviation remain exactly the same. So I'll say equals there. And that gives me my lower quartile as 17 point, that's 9, we'll go 8, 8. That's perfect. And now the upper quartile, so one more sketch. Here we go. Mean in the middle again, 19. And our upper quartile, let's put that maybe on this side here, we'll call that one T, let's just say. And the area to the left of your upper quartile is going to be 0.75. So let's put that at 0.75. There it is. And we'll again stick with inverse normal. So we just put our area as 0.75. The mean and standard deviation stay exactly the same. And so there it is. We've got our upper quartile as 20 point, we'll go 0, 1, 2. There we go. Awesome. So that's our upper quartile. And this here was our lower quartile. And so to find our interquartile range, what do we need to do? We need to do a little bit of subtraction. Take away your lower quartile from your upper quartile. So that's going to be 20.012 subtract 17.988. So if you can, make sure you use the whole values, right? When you're doing this, I'm just going to use the rounded ones just for now. And so my interquartile range comes out as 2.024. And there it is, all done. So there we go. Normal distribution question number 3 sorted. Now, remember, if you've got area to the left-hand side, you're going to be, possibly using that inverse normal function on your calculator. So do get used to that over there. More normal distribution coming your way, so stay tuned and I'll catch you in another video real soon.